All right. Good morning, everyone. My name is Chad Medcroft. I'm Vice President of Products here at Lumeta Solar, and I'm basically leading up the product management, field applications, and training here at Lumeta. I've been in the industry for about 20 years with various different companies like Solar City, SunPower, and Fronius. Um, and in my spare time, I do research on the sun. You can see that today. Don't need to adjust your computers. Might be a little red tint on there. Pass it on, Mike.
Hey, good morning, everybody. I'm Mike Nichols. I'm the field applications engineer for Lumeta Solar. Happy to be here today. I've been in the solar industry, started out installing in New Jersey back in 2010. I've had a lot of field experience, and I'm really happy to be working with the team, bringing that field experience to help make sure all the products are ready for the field.
All right, so let's dive right into it. First and foremost, we're going to talk about what issues traditional solar has. So we all know that solar modules, inverters, racking system pricing has come down dramatically over the past few years. Um, Unfortunately, labor costs have not come down as quickly. So we're starting to see that as a much greater portion of the overall system cost. Also, you know that you're putting 100 or hundreds of penetrations in the roof that can lead to potential leaks. Um, every single hole you're making has the potential to wreak havoc on the homeowner system. Next, we've got various different parts, everything from racking bolts, nuts, etc., that have to be managed, ordered, and procured for every single job. These systems are adding structural loads to the overall system, so sometimes that may require rafter upgrades or at least some verification there.
Structural stamp, something like that.
Exactly.
Extra money and time.
Exactly. And then, aesthetically unappealing systems are out there. We're seeing rails protruding. We're seeing modules that just don't fit well with roofs and stick up. And those systems that are BIPV, so building integrated, that may have a more aesthetically appealing advantage to them. The challenge is that they oftentimes lower the production because they're not allowing airflow underneath. So again, here's sort of a good summary of some of the issues that we're seeing in the field today.
So obviously the product has a lot of obvious benefits from an installation standpoint, and here are some of those benefits right here. As you can see, it's a faster installation, it's a smaller crew. If you had a chance to take a look at that video of the installation that was included in your invite, you'll see that this installation was 12 modules, about 3.6 kilowatts, installed in 32 minutes with just two guys. And that's 12 modules with all the wiring, connecting, everything completed in just that short amount of time. So that being said, it's a much faster install, smaller crews, no penetrations on the roof, which just means less time, less liability, and lots of other great benefits of the product.
So let's back up a quick second. We'll tell you a little bit about the Lumeta story before we dive into the adhesive and attaching and connecting specifics. Lumeta was born from roofing, which basically means that our co-founders, Brian and Tim, have been in the roofing industry for 30 plus years. One of their big clients, a big box retail customer, was looking to them to solve an issue that they had some roofs that couldn't withstand a lot of weight, and they also didn't want any penetration. So that was where the product was born. Started out as a large format commercial product that was adhered directly to single ply membranes. And over time, it caught the eye of Department of Energy. So it was granted a Sunshot Initiative plug and play program. And from 2013 to 2015, it went through extensive testing through Fraunhofer. And also got reformatted into a residential product that was designed specifically for shingle and for tile roofs. We received a certification for that module shortly thereafter, and more recently we've been reformatting the module more standard size, so a 60 and 72 cell, and focusing in on addressing wire management and aesthetics as we've done that work as well. The Lumeta module itself, just talk through a little bit of the construction of the module. We start off with a high efficiency monocrystalline PERC cell, which is quite different from most of the other thin film or thinner modules out there, those modules that adhere to the roof as well. We also focused really on getting the weight out of the overall module. So we start with a fluoropolymer top sheet, which replaces glass. So a lot of benefits, not only lightweight, also allows for heat to dissipate, and also it prevents the possibility of cracking glass as well. We also have on the back side, we've got a fiberglass enhanced polymer for a back sheet that will create stability and protection for the cells. And then along the edges, instead of a standard frame, we have an edge seal, which is a patented component that, again, reduces weight and eliminates the potential for dirt and dust to collect around the perimeter of the module itself. And then lastly, the adhesive is attached to the backside of the module, and that attaches directly to a shingle, a tile, or a membrane roof, and again eliminates the need for racking of any sort. And from this, we use tier 1 suppliers for all of our products, including DuPont and some tier 1 cell manufacturers as well.
So without further ado, meet the Lumeta Lynx 60. This is our 60 cell module right here. This is up to 310 watt power output, standard monocrystalline silicon cells in the module. And again, this module has all the benefits that we featured in the last slide, talking about the low profile, the sandwich. The biggest thing with this module is you can install it directly onto shingle surfaces. So you can install it directly onto comp shingle roofs. You can also install it onto tile roofs using the foam inserts, which we'll talk about in a few slides. Our other modules are Lynx 72. So this is our commercial focused module. It's up to 370 watt power output. Again, this is monocrystalline cells as well. And this module has really been optimized for flat and low slope commercial roofs, with the adhesive pattern being optimized to keep water intrusion out of the center of the module. So you can see here from these slides that we've done a lot of testing on the modules, UL testing, as well as intense shipping crate, fire testing. They've been through extensive wind tunnel testing at multiple facilities with great results. We've also put all of our products through extensive real-world robustness testing using a protocol that we made in cooperation with Black & Veatch.
Great. All right. So let's move on to the attaching Lynx 60 comp section. And here we're going to talk about our adhesive technology. So first, starting off, it's important to note, as we described a moment ago, that the Lynx 60 attaches directly to the shingle roof. So there's no racking system. There's nothing else needed between the module and the roof itself. As a result, you have a low-profile module that has done exceptionally well in wind tunnel testing results, and also there's no deflection of the module, the cells themselves, in greater snow loads. So we're able to endure higher, be installed in higher snow load capacity locations, and also do really well in hail tests as well. The modules can be easily removed, which is another huge benefit. And so it's, there's obviously numerous advantages from this adhesive technology.
So yeah, the technology is easier on roofs and easier on installers. You can see by the number of points there, all sorts of things. The lack of penetrations, not having to hammer out rafters, not having to rip shingles, pry shingles up to flash underneath or install flashings themselves. Literally just lay out the roof. All these benefits here. No trimming rails, no hanging off the edge of the roof. And one of the biggest ones I love is not having to go down to the gutter and fish things out of the gutter or walk around the customer's backyard picking up hardware at the end of the day.
Yep, I've done that more times than I'd like to admit
Definitely.
to. So we've also designed the adhesive pattern to allow water and air to flow either in portrait or landscape mode, which allows for it to cool off, also allows for any debris and so forth to not collect on the roof in that manner. The adhesive also has been designed to maintain its full strength throughout the entire temperature cycle, and that includes down to minus 40 degrees Fahrenheit all the way up to 200 degrees Fahrenheit as well. And again, as I mentioned before, the fact that the module is flush mounted allows for much greater wind loads and snow loads to be withstood as well.
So adhesive is obviously not a new thing. It's been a part of all of our lives. It's trusted across many industries, and it's used in automotive, used in aerospace. It's used to put together space shuttles and satellites, jets, things of that nature. So it's used in automotive for a lot of things, things that we use every day and that are part of our life. Adhesives have been used more and more in manufacturing in recent years. So it's not a new thing. It's a trusted technology, and so we're excited to integrate it into solar.
And I think it's important too to know that the adhesive that we're actually using has been used in the roofing industry for
Absolutely.
30 plus years. So it has the reliability and durability to withstand the specific environments that we're putting it in. Exactly. So we also have extensively gone through various testing for the adhesive product. And the product in general, but it withstands the adhesive aspect of it. So we've tested it through highly respected testing agencies, national recognized testing laboratories. We've been through testing through Fraunhofer, again, discussed Department of Energy Sunshot program. Black & Veatch has helped us to create our robustness reliability testing. And we're currently going through third-party structural engineering verification, doing every imaginable thing to validate that at that level. We've just gone through UL 1703 testing for our 60-cell module. We'll be going through that shortly with a 72-cell module, and we've already passed with our smaller format module. And again, we've gone through wind tunnel testing and fire testing for smaller format. We're about to go through that right now for the 60-cell module.
So an important technical note before we get into the step-by-step installation process is two very important things to make sure every time you go to install a Lumeta system is that there's absolutely zero moisture in the area where your array is going to be installed. You want to make sure you have a totally clean surface, it hasn't dried, there's no mist or moisture or anything of any kind on that shingle surface, and also that the temperature is above 40 degrees Fahrenheit. These two things are extremely important to make sure that you get a good bond for your system when you first apply them.
And I think again, it's important to note that roofers have to effectively adhere to these two requirements and roof around the clock, around the year. So I think that's again important to be able to note going through this as well. All right, so let's go through steps of the install process. Again, if you haven't already seen the video, there's a link that was sent to you recently, so click on that link and you can watch this short video. So the first step is to measure out and mark the roof, not unlike you would do for your standard array. And for this array, we need basically 1/4 inch spacing between your modules in both east-west and north-south direction. And note that you can install all the way to the edge of the roof. Sorry, let me go back to that slide. Okay. All right. So that concludes the first step. Let's move on to the second step.
Yeah, so once you get your layout done on your roof, you want to go ahead and clean and prep the surface. And so it's a really important step. Make sure that, especially for older roofs or roofs that are not brand new, you want to make sure you take the time to sweep off any extra granules. You can actually even use a leaf blower like we do in the video there. Basically, what you want to do is just make sure that you get any sticks, leaves, debris, any extra granules that are hanging onto the shingles, blow that off the roof, and then you're going to go ahead and install your modules right over that area where you just cleaned off.
All right, third step is to prepare the modules for installation. This is pretty straightforward. There's no need to, get wire clips or put attach either a microinverter or an optimizer or anything like that. All you need to do is pull the release paper from the back to expose the adhesive, lift it up to the roof, either lifting it on a single story or hoisting it on a 2 or 3 story roof, and then start to attach it.
Okay, so now just get your modules prepped, and if you pass them up to the roof on a nice easy 1-story like in our video there, once you get your modules up there, go ahead and start aligning them with your chalk line on your roof. And so you're going to have a starting edge chalk line that's running horizontally across the x-axis of the roof there, running parallel to the gutter. Go ahead and drop your modules in just in that fashion that you see in that photo there. You want to line the bottom edge of your module, standing holding the top edge where the wire tray is located, and go ahead and just lower the module into place, making sure that the bottom edge stays aligned with your chalk line, excuse me. And so you really just want to make sure that this first row gets put in perfectly square, because after that, it's going to be really easy to drop your other modules in, just like with regular standard PV. It's really just to make sure aesthetically you have a good looking array at the end of the job.
Yeah, the nice thing with this process as well is that you avoid having to go really close to the gutter, which is usually the most dangerous part of the roof as well. All right, the next step is going to be to apply pressure to the module. Really important to apply 40 pounds of pressure, whether you're using a roller or your hand, to make sure that the adhesive sets in properly and starts the process of wetting into the roof.
Definitely. So now let's get talk about our adhesive inserts, which is our solution for installing our modules on tile roofs. So the insert, as you can see there, it's a foam insert, and as you can see there, it has the adhesive attached on it coming from the factory. So all you have to do here, no pulling tiles or grinding tiles or hammering out underneath the tiles to find your rafters, then drilling it out, sealing it, all these things. Forget all those steps. All you literally need to do is peel that piece of release paper, that plastic liner that you can kind of see in the image that's on top of the adhesive. Just remove that liner, stick the insert directly onto the tile surface, and then you can adhere the module directly to that. So it's obviously a much quicker, much more straightforward process for installing on tile roofs. So you can see a photo there of our module installed on a flat tile roof. And as you can see, it's extremely low profile, and that is the module installed on the foam inserts. So the foam inserts are in the gaps there on each tile course, and the module is directly adhered to those foam inserts. And so you can see, even just by looking at that image and knowing what you know already about the product, how many obvious benefits there are, especially when it comes to a tile roof. There's no penetrations, no pulling or breaking tiles, carrying replacement tiles up to the roof, replacing tiles with tile flashings, or all sorts of different things that we've tried to do in the industry to make tile installations easier. This, you're skipping messing with the roof at all. You literally just install directly on top of the tile surface.
Great. All right, so thanks for that, Mike. So next we're going to move into the next section, connecting Link 60 and talking about our integrated wire management solution. So I can't stress this enough. One of the biggest challenges installers face in rooftop PV is proper wire management. I've inspected well over 500 systems out there, and time again, you see modules that have conductors that are either pulled too tight, running across sharp objects,
hanging on the roof,
and bad bend radiuses that are creating ground faults.
There's a lot of challenges with standard trying to manage wires on a racking system.
There is, for sure. And so this is a quote from Pro Solar magazine, where it basically states that wire management continues to be the Achilles heel of the majority of PV installations. And certainly my experience and Mike's has validated that as well.
Definitely. So as you can see there from the photo, touching a little bit on our integrated wire management. So that there in the photo is the integrated wire tray that'll be installed at the top of every module coming from the factory. And so that wire tray right there, we're really excited about it. As you can see from the photo, there's plenty of bend radius for the conductor there. There's plenty of room to put your home runs, your jumpers, to make your connections. You can even get your fingers in there and manage the wires and do whatever you need. No zip ties needed there just to manage your wires. You simply use the wire channel itself to manage the conductors. And again, there's plenty of room there to make code compliant bends.
Right. So moving back to our sequence of steps here. So the next step after the module has been adhered and pressure has been applied, now you're going to connect the modules when the row is complete. So using the integrated wire tray is provided, basically going to make your quick connections between modules at that point. So this next photo shows that, and again, it's very easy to do, very easy with the wings that we've incorporated into the wire tray itself. They will easily retain your connectors and your conductors inside of that area there as well.
So the next step, once you have that done, is to attach the wire tray covers and end caps for the row that you just installed. So as you can see there in the photo, we just put the first row down. You want to make sure you always install your wire tray covers before moving on to your next row of modules. Really important step, just makes everything easier. And the tray covers will be come in 10-foot lengths, so it'll make everything easier, 3 module lengths. So you literally just pop those tray covers in place on top of the wire management section, and also install your end caps as needed. It's usually easy enough to just pop your end cap in on the end as you go along, and we'll actually see a photo of that, I believe, in the next slide there. So yeah, you can see those photos. On the left there is obviously attaching the wire tray cover. So it's as simple as just attaching it, aligning it with the grooves on the wire tray, and pressing it into place. The end cap is very similar. Just align it to the grooves once you pop it in place, and just push in using pressure, just install the end cap right into place. And it's designed so that the tolerances will actually keep the end cap in place. You don't need to go get a screwdriver, get off the roof, or get a tool just to install that one thing. Just pop everything together, move on to your next row.
And you can see from these images that it really is a finished product that we've thought through, and so it looks aesthetically appealing once the tray cover as well as the end cap is installed as well.
Definitely.
So the next step is basically going to be to repeat that up the roof. So after each row of modules is attached, you'll connect the rows together, and then we'll incorporate the home run wire management system, which we'll describe in just a moment.
So once you've got the home run tray system in place, you want to complete the rooftop wiring. And so you're going to do that by routing all your conductors through your home run tray, as well as finishing routing your conductors through your top row of modules. Depending on what your HJ requires, transition to a rapid shutdown box if needed. So as you can see in these photos here, here's some of our home run tray components. And so in the top left there, that's a photo of the actual wire tray itself. Just wanted to give you guys a full open idea of what the tray looks like with the cover off. And so you can see that there's plenty of room there for bend radiuses. That's about 4 inches wide in there, by the way, just to give you an idea of reference. There's plenty of room to run your conductors, home runs, jumpers, plenty of room for connectors and everything. If you go to the photo to the right of there, top right, that's actually a 90-degree or a L section, which basically allows you to route your home run tray 90 degrees in whichever direction you need on the roof. So as you can see in that photo, that's a photo of the conductors transitioning off the module onboard wiring and transitioning onto the home run tray. And if you look at the bottom left photo, that's a photo of the actual transition piece itself to give you a little closer up idea. And that's actually a component that fits over both the onboard wire tray as well as the home run tray and connects the two together. And you can see in the bottom right photo, that's just a photo of our T accessory as well. So we have a way to have intersecting home run trays, or if you had another row of modules that you wanted to connect, you can use that T section to complete that wiring that way. So obviously you can see it's a lot of great benefits to these components.
Yeah, so we've designed this to minimize the need for cutting, especially in these harder angle cuts in the L and the T shape. So yeah, it enables you to have a much more aesthetically pleasing system on the roof.
Definitely. Basically, all you would need to cut is your wire tray and your wire tray cover. Cut that to size and use these different components for your intersections.
Okay. All right, so then in summary, those are all the steps for the installation process. So now we've got, again in the video, you'll see that we've installed 12 modules, so a 3.6 kW system, assuming 300-watt modules in around 30 minutes. That was with just a two-person crew, absolutely no penetrations whatsoever, and very minimal parts in this whole installation process.
So yeah, now to talk about a little bit about our rapid shutdown solutions and how our product integrates with the current code requirements for rapid shutdown. So talking about 2014 NEC, the first option here, or one of the options I should say, is really to install a rapid shutdown UL1741 listed device, whether it's a pass-through or a combiner box on the roof. That really depends on your inverter technology and what kind of systems you're installing. But basically just wanted to give you guys an illustration showing that we do meet similar code requirements. So to meet the 2014 NEC, use a string inverter level rapid shutdown box device on the roof. Put that near the array within 10 foot of the array per the code requirement, and run your conductors down to your inverter. That's basically a 2014 rapid shutdown compliant array there. And as you guys know from the installation side, there are a number of ways to achieve 2014 compliance using this same diagram, whether it's running through the attic or whatever your situation is. Another option for 2014 NEC, if you go to the next slide, is my favorite option, which if your site allows it, have your array within 10 foot of your inverter, and there's no need to comply with 2014 rapid shutdown. So that's always a great option there. Keep that in mind. So really those are our two options right now, and obviously there's a lot of different ways that you can cut the cake of how to run your conductors and have a rapid shutdown box within 10 foot of your array. So there's a lot of different ways to address that. And yeah, basically just using string inverters in our modules.
Yeah, and there's a number of off-the-shelf rapid shutdown solutions currently available and listed that we will share shortly in a document.
Yeah.
That highlights that. And so again, I mean, the one aspect of our module today is that they will not they're not compatible with microinverters or optimizers such as SolarEdge, but there's a whole host of great solutions out there with rapid shutdown boxes and string inverters that will enable you to utilize those today. For 2017, which the 2017 NEC rapid shutdown, so 69012, basically options 1 through 3 are going to be required from January 1st of 2019, and there are a host of ways that we plan to adhere to that and achieve that. One of the ways, which would be the easiest way, is referring to 69012 B2 option 3, which I'll read it here. It's PV arrays with no exposed wiring methods, no exposed conductive parts, and installed more than 2.5 meters or 8 feet from exposed grounded conductive parts or ground shall not be required to comply with 690.12b. So
what does that mean?
What does that mean? Basically means that if you have no conductive parts, so in our module, we basically have no metallic frame. So there's nothing that can be energized around the array itself, which is quite unique in the industry. Secondly, it says no exposed wiring methods. So our wiring tray, our home run tray, basically an entire wire management system prevents your wires from being exposed and provides a method to to contain them and to protect them. So with those two, basically what we need to do then is to have a method of creating a rapid shutdown solution within that boundary, that 2.5 meter or 8-foot boundary, using a non-metallic solution, and then that's your rapid shutdown solution. So we're, in addition to that, so I'm on the UL standards technical panel for the new standard coming out, UL 3741. So we're following this very closely, and we'll be testing early to make sure that our product is compliant with that. The other option we're looking at is integrated module level electronics. We're discussing that with some key players out there. So hope to have a solution that has integrated optimization at the module level with potential rapid shutdown feature as well. So lots to come, and for those of you in California who won't really see this until 2020, got a little bit more time for compliance of 2017 NEC. All right, so that pretty much wraps up the bulk of our presentation. We want to let you know that we have plans to do pilots in Q2 of 2018, so later on this quarter, and then we have plans to be able to do a major market release in Q3, so later on this year. Please register your interest by signing up with our newsletter. You can click on that link there, just go to our website and enter your contact details, and that'll get you the latest information on our release dates. So thank you very much. What we'll do now is open things up to Q&A, and hopefully you guys have lots of awesome questions to stump us with. Any questions?
Anything coming in?
No.
It's just me.
Yeah, so if anybody has any questions at all about the product, I'll hang out for a couple seconds. Definitely interested to hear you guys' feedback, even if it's not a question. If you have feedback, constructive thoughts about the product or anything, we're happy to discuss. We got somebody typing a question in now, so give that a couple seconds to come through. Yeah, anything, I mean...
Actually, maybe we can just show some of the...
Yeah, sure, yeah. So we have some of these components here that we talked about in the presentation. And so here's one of the components right here. This is the home run tray off-board wiring that we had discussed there. And so I'll open this up so you can see it, but that's the tray with the cover installed. I'll go ahead and remove the cover. I'll kind of try to do it slow motion so you can see, the process. But once you remove it, there's the tray. It's already got an end cap installed in here, and so you can see we've got tray, end cap, pops right in, tray cover goes right over. Everything fits right together. We can use that for off-board wiring.
Okay.
We've got a question here.
Yeah, so let's address this first question. So it says, can you please explain how it is removable? Does it tear up the comp?
Yeah, definitely. So first of all, to answer the part about does it tear up the comp, no, it definitely doesn't tear up the comp. It's a great question. So what we do is we heat the module, and the process for removing the module is to heat it up using a blanket. And so use a construction-grade utility heating blanket. These can be purchased online from multiple construction sources. Basically, use this blanket, lay it over the surface of the module, plug that in, heat it up. Takes about 8 to 10 minutes to get the module up to temperature, and you can go ahead, and that will actually break the bond between the adhesive and the roof once it's heated up enough, and that will allow you to remove the module out. And the temperature has to be over 250 degrees Fahrenheit for the surface, the adhesion to break. And so that's basically how you remove it. It's using a blanket, one at a time. And no, it doesn't tear up the shingle. Once you remove the module, you can actually take a little bit of extra roofing granules and just sprinkle those over the areas where there might be a little adhesive left, and that'll blend right back into the roof.
Great. All right. Thanks, Mike. So another question came in. Says, I'm a Florida homeowner. We have code requirements for hurricane wind loads. And let's see here.
Yeah, I've done some wind tunnel testing.
Yep.
Require structural engineers sign off for wind loading.
Yep. So real short answer is that our code compliant letter will address various different regions throughout the country. I realize that in certain parts of Florida, specifically Broward County, generally has much, Dade County and Broward County generally has much higher wind load requirements and special testing required. So we may not have those particular counties certified out of the gate, but we will address most areas, and our preliminary numbers look very good that we should be compliant with the vast majority of Florida. So I don't anticipate any issues there.
So yeah, there's another question. I believe the next one was, once removed, can the modules be reinstalled? It's a great question, and the answer is yes. The modules can be reinstalled after being removed. Removal process doesn't do anything to damage the module components at all. Once removed from the roof, there might be a little bit of granule stuck in the adhesive pads on the back of the module. All you would need to do is simply replace those adhesive pads, and not even replace them, but actually just add more adhesive over the pad that is on the back of the module, and that adhesive is something that will supply you with. So once you get that adhesive, the pads will be cut into size. You literally just stick that pad over any pad which need replacing, and that module can be reinstalled on the roof.
Great. Next question is, what wattage are the modules? So we are going to be using a variety of different high efficiency cells. So there'll be various different power levels for the 60 and 72 cell. Right now, our plan is to have likely a 280 to 310 watt module option for our 60 cell, and we'll be probably around 350 to 370 watts for our 72 cell module.
So great question. Another one coming in here. Definitely keep the questions coming. These are all great. Standard modules need proper airflow around and under the modules to maintain efficiency. How do you address this concern? It's a great question, one of the biggest ones we get. The biggest thing is the technology of the module. So with our modules, the front sheet is not glass. So there's no glass in the construction of the module itself. It's a fluoropolymer front sheet. So think of more like saran wrap stretched over the surface of the module that holds everything together. There's not going to be any glass shattering or anything like that. No glass, greenhouse effect that you see with standard modules, as you've probably heard. Basically, that heat is designed to shed through the front sheet, through the thin layer, the fluoropolymer front sheet, rather than standard modules are designed to shed their heat through their back sheet. The other thing is also that the substrate the module is installed on basically creates a straight line over the shingle courses. If you imagine the shingle courses or the tile courses somewhat in the shape of a Z, and the module is a straight line over that. The areas where there's gaps, there's actually thermal breaks there, and there's airflow under the module as well as on top. So because of those thermal gaps, as well as the fluoropolymer front sheet, that's how the module is designed to shed its heat through its front sheet, rather than a standard module, which is designed to shed through its back sheet.
Yep, great. Next question is concerns about the butyl attachment to tile surface in dusty tile roofs. How do you test for real conditions? So as part of the process of installation, you will need to clean off the tile roof. So we're not going to, you will take off the layer of dust and dirt to clean the roof surface. So in that fashion, basically you're adhering to a clean surface of the tile. And that has been tested in under wind tunnel testing conditions. So we have experienced real world conditions for that particular application.
Yeah, basically you're using a wire brush or something like that to quickly scrub off the surface of the tile, and then you're using a concrete sealer to pour over that, and that creates a nice bonding surface for the module. How do you connect rows of modules? So yeah, the connecting rows of modules, it's another big question. So we talked about that in this presentation, and that are the different components for the home run tray sections. So basically we have components. I'm not sure if you want to go back to the slide so we can just take a look at it. So there you can see there, particularly in the top right photo, that probably gives you the clearest sense of how the conductors actually transition from one row of wire trays to the next. And you can see there that 90-degree section there is connected to the wire tray, which is running to the next row of modules. And then you would install either a T or a 90-degree section at that same area to connect into the wire trays of that row up from there.
Yeah, so obviously you don't have the ability to run your conductors on the underside of the module because there's no space there. So this is our solution, which we feel is aesthetically pleasing. It keeps the conductors off the roof and well protected. All right. Have target price points been established for the modules? We're still working out final pricing at this point in time. We're targeting somewhere for the 60 cell module, somewhere in the $1.30 a watt range, which we feel, keep in mind that includes your racking as well as your module, and it's basically a low profile, aesthetically pleasing system that will save you tremendously on labor. So at the end of the day, we feel that is a competitive price that will bring the overall system cost at a very competitive level to your standard PV as well.
So I see another question here. Great questions, guys. Definitely keep them coming. It's great stuff. So this is an awesome question. You mentioned UL 3741. What standard is that? I'm really glad you brought that up because I'm sure you're not the only one that is unclear about what UL 3741 is. Chad could tell you more about it since he's on the standard testing panel for the codes, but I will tell you that UL 3741 is a UL standard that is being developed for certain products, and basically it's for PV hazard systems. And so the term rapid shutdown has been something that's been used in the industry and in the National Electrical Code. But as we all know from installing these systems, they're neither rapid nor are they completely shutting everything down. So the term rapid shutdown really isn't an appropriate name for these types of systems. So industry professionals are working on creating a new standard that will help define these type of systems, and that standard will be UL 3741.
Yep, exactly. So it's a great explanation. So basically, it's going to be developed over the next 6 months, hopefully, to give an advanced ability for module manufacturers and other technologies to list their products to this in advance of the 2017 NEC coming to fruition in 2019. And it's a PV hazard control. Mm-hmm. So effectively, as Mike alluded to, it's not only just a particular component, but it allows an entire system to comply to this this requirement that was previously listed as rapid shutdown. It's basically going to replace that as a new standard. Okay, next question. Will your panels integrate with Tesla Powerwalls? Good question.
String inverters. So the modules are compatible with string inverters. So it depends on which string inverters you're using, installing, and whatever you're using. So if your string inverters that you're using are compatible with Tesla Powerwalls, then you're good to go. Design the system based on that. Our modules are compatible with most string level inverters. They are inverter agnostic. So whatever you want to use there. So that's basically the answer there. As far as designing your system, if your inverter is designed to be integrated with a Powerwall, then yes, it can be used.
Yeah. And I believe the latest version 2 of the Powerwall has an integrated inverter in it as well, so that basically this acts as any other standard module out there, so it's definitely compatible with the Powerwalls. The next question, how are you grounding the system? So again, we don't have any metallic parts in the module itself, and your conductors are not exposed. So there's no need for equipment grounding conductor, except if you introduce, say, a metal junction box or disconnect or combiner box along the way, then you would have to run your equipment grounding conductor from that point forward.
The system is essentially an ungrounded system, or if you're using the new terms, functionally grounded.
Oh boy, that's a tough question. The next question is, can installers walk on the modules? So
on a pitch, you don't want to be walking on them anyway, right?
The official answer is no, and any module manufacturer will tell you that you don't want to compromise and introduce the potential for cracking cells, because there is pressure on that. That being said, we have done extensive robustness and reliability testing internal, where that's actually one of the tests that we do as part of the R&R testing, and our results show that you're not introducing
Hi everyone, if you can hear me, we're just reloading. Apologies, we seem to have some kind of break in the matrix.
So
audio, sorry.
Okay. All right, so we're back. So sorry about that. It must have been my response to that question. Blew up the internet. So yes, we have done extensive testing internal where we haven't shown any damage to cells through walking on it, but still, if you're on a pitched roof, it's never a good idea to walk on the modules.
We've tested them. They can handle it. Would we say that you can walk on them? No. So I hope that answers the question. We welcome any other questions. All the questions we've gotten so far have been really great.
All right. Well, if we don't have any other questions, wait.
Yeah, we'll just hang out for a minute. Feel free, think about it. If you have any questions, now's a great time. We're here, we're willing to. Even if it's not a question, again, if it's a comment or any thoughts or anything at all constructive. Where/how is the 40 pounds of pressure applied? That's a great question. So you apply that over the surface of the module. And so in the video that we put up, you actually were using a roller tool, which is essentially a vinyl flooring tool, which is designed to do the same effect, which is apply enough pressure to get the adhesive on the vinyl flooring to adhere to the roof. So you can see we're using a tool there. Essentially, you want to make sure you're applying the pressure over the surface of the module, so the area where the cells and the front sheet are. And this process has been extensively tested to make sure that there's no damage occurring from the use of the tool. And we've also tested it using just your hands. So if you're going to use your hands without the roller tool, you can use the palms of your hands to apply pressure to the surface of the module. And you just want to apply a decent amount of pressure. You're easily going to apply more than 40 pounds of pressure over the module just by putting a little bit of weight on it and pressing down. But yeah, the pressure is going to be applied over the surface of the module. The easiest way to do it is with your hands. You can also use a roller tool, and we're also working on developing a custom solution for that as well to make everything easier and quicker.
Great. All right, thanks for that question. Do you see any others coming in, Marcia? Okay. Great.
You got one more question coming? All right, great, awesome. Keep them coming for sure. That's what we're here for. So, love to hear it.
Will the modules be available for DIY? Our intention is out of the gate to make this more specifically for the installer networks. It's any time you have a lot of details in the installation process that from any, it is a very simple installation process, but there there's always devils in the details for conducting your or bringing your conductors off the roof properly, connecting to an inverter, all those things. So I wouldn't recommend this as a DIY, just as I wouldn't recommend any solar today as a DIY project. But if we, I should say, we wouldn't roll that out for future products as well. All right. Great. Well, thank you again. Appreciate all the questions and your time on the call, and we look forward to having you guys, seeing you up on the roof and working with you guys. We'll certainly be helping to participate on initial installs and making it as easy as possible for you guys to transition to Lumeta.
Definitely.
Thanks for your time.
Thanks so much, everybody. Have a great day.